Welcome on stage Dominik and Robert from Adobe with their talk Monolith to Modules and how to actually break applications apart into modules. Let's welcome Dominik and Robert on stage.
From monolith to modules might sound like we are about to talk about a bigger breaking change to come with AM, but that's actually not the case. It's quite the opposite. Like, we're talking about how we try to get from a big monolith that we shipped over the years to more modularized systems, and the experience that we had on the journey, and sharing some of the patterns and some of the lessons learned from this exercise. So, my name is Dominik Süß. I'm software engineer in the Cloud Foundation team of AM, primarily focused on the deployment experience of AM.
So I'm Robert Munteanu. You see me a bit earlier. I'm the PMC chair of Apache Sling in Adobe in Basel. I'm working on a Cloud Foundation team, which handles, well, foundational stuff for clouds, let's say. Right.
So in the next 20 to 25 minutes, we want to cover a bit of the benefits and costs of modularization and how at least we experience that. The various patterns, Robert will go into the part of decoupling patterns and more of the technical side of things on how our specific stack can utilize those patterns. Then we will have a look into the tooling support around specifically about what we have with feature model and how that can be used to analyze parts of modularization and how this can be governed. And after that, I will also get into the part of keeping the QA effort under control, or more or less, like, what is the problem with Q&A and modularization and why there is such a big impact. So let's get into the benefits and costs. Like, benefits is pretty simple. If you have modularization and if you don't deploy all the modules at once, like if you don't actually need the monolith, then you get a slimmer installation. You get a slimmer installation and you have overall a thinner footprint on all kinds of hardware resources, and also from what you have to focus on, it gets a lot simpler. This can be the development experience. That's for our own engineers, like, they have to focus on just the module instead of keeping everything in their, like, the impact on everything. That's something you don't have any longer. But on the other hand, it's also about the experience that you as ecosystem, as the ones that are consuming the APIs, will be significantly simpler, as you have to make sure that for a project you only need this and that module. So you have a clear API surface for a specific module and can ignore everything else. So next, and that's one of the most important ones, I personally think, is the reduced impact of bugs. Like, as soon as you start to modularize, you have clear areas where you can locate a bug, and as soon as you find that, only the customers that are depending on this module need to be fixed. And if you, like, at the scale that we're currently rolling out AM, this can make a significant difference if we have to patch all of our customers or only a fraction of those, because only those ones depend on this particular module. Next, having clear dependencies is also a big benefit that we have. We can govern the dependencies between the modules. We can see the impact of changes to a module and see how much effort it will take to adjust all the consumers that we have out there. Like, this is really a major change that has undergoing for the last years, where we have seen that just exposing everything and across the board over the product and to all the consumers takes the control completely out of our hands. This also comes with the part, like all of the points ahead accumulate in a part of, like, we have the opportunity to have decoupled module life cycles. So we can release modules independently and therefore also can react a lot faster to any kind of business needs. So we can, prepare a drop-in replacement for a module, so we can be quite innovative and have new modules and still ship an old version of the modules as kind of frozen state in between. This is a pattern that we also follow for AM 6.4 and 6.5 for the sake of backward compatibility. So this is really making sure that we can move as fast as we want without breaking our customers. So this flexibility comes with a cost. And the cost of flexibility most of the times is complexity. And this is the complexity of API governance, so therefore we have a lot more different APIs, and we have to make sure that those ones, the versions that you can combine with each other, are compatible, and that also you as consumers know which versions you have to look up, like how you combine the various documentations of APIs, how to bind to the various APIs. There's a lot of additional steps involved that we have to consider, and really have to consider if they justify to take things apart, at least as they are exposed. The planning and testing for the absence of modules is also a critical part, because this is a fundamental change on, like, if code is just not executed or code is not present, might make a big difference. This is not just the positive sides on the footprint side, but also about, yeah, some stuff might have kind of expecting some code to be a no-op, in a no-op mode. And if you take away that module and the code is not present, you don't have this. So you have to plan for that and develop corresponding code that takes care of that. And we'll get to that with the patterns in a bit. Also, I did touch on the documentation. Like the whole deployment and maintenance procedures, if you just think about the AM documentation, it is currently, as it is, linear in its way that you can always look into a specific version and look how the documentation looks for that. You also have interfaces that are optimized for everything together and configuring it in one place. As soon as we tear apart and have separate modules, we might need to split those interfaces because they evolve in different cycles. This can make procedures, probably you have one or two additional clicks, or you have to configure stuff in different interfaces that hopefully are pretty well integrated with each other, but still it's something that we have to change. And the same thing that, like, you as a consumer, on a human consumer, also applies to automation. As soon as you start to talk about continuous integration setups or continuous deployment, rolling your software into actual systems, you need to take those aspects of modularization and different life cycles and how they relate to each other, take those into account, which can also be a bit of extra code and extra analysis that might need to be in place to handle that. So for us, that meant, like, 2 to 3 years ago, we noticed that we need a plan for AM. Like, the reason why we had to change things is the growth of AM and the addition of new modules and new functionality that is not there or should not be there out of the box. One of the first attempts was AM Forms, which is an add-on module, which is not entirely following modularized patterns, but this is really where we learned kind of the hard way how hard it is to keep an add-on module in sync with the core product and how to manage those dependencies. Based on that, we identified the need that we need to have better ways to describe the modules, to analyze the modules, and to get those properly together. One of the outcomes, and like for subsequent activities, was the feature model as a way to clearly describe the stuff that we previously couldn't properly describe in a metadata file. And then, and this is really, Robert was the one that did the first cut to really see how this takes off and do a first cut, like not really tearing apart in a lot of tiny modules that we handle, but really one first cut to see how we can get a core product with everything that's optional aside and see how we can manage that. So we will not be talking about the business side and how this will be shipped or what we will do with that. But this is about how we got to the point where we can provide our product managers the opportunity to decide how they want to ship that and how they can expose that and know about the cost or the implications that this will have. And with that, handing over to Robert to talk about some of the patterns that we found.
Thank you. Now, this is where the good-looking slides end. I can only draw bubbles, sorry. So first I'll be talking about some OSGi decoupling patterns. So one feature, Dominik was talking about features and how they group and they switch. So one example is you have two modules, I said here, billing and messages. And they are two well-defined, isolated modules, features, and they communicate using this, I call a glue bundle, which groups the common, dependencies. That this is the only place in which you have both dependencies to billing and to messaging. So that's one pattern. That's one way of encapsulating dependencies, to make sure you have a clear, separated boundary between the two modules. So the plus side is that you have a very small, isolated unit which you hold these dependencies, and they do not leak out anywhere. So if you're there, that's great. If you're not, getting there can be difficult. So if you want to refactor such a glue bundle or a glue module, it can be very easy to mess up backwards compatibility. So if you do not have cohesion at the package level, so for instance, you have com.company.foo, and that foo package contains dependencies both that you want to extract and that you want to keep, you will break backwards compatibility, right? Because you delete stuff from your package, export the API. So you will break backwards compatibility. So that's one downside. Refactoring can be difficult. On the other hand, you must not forget, right? So if you deploy module A and deploy module B, you need to remember to deploy the glue that keeps them together, that binds them together. If you forget that, there will be no warning signs, no exceptions at runtime. Things will simply not work or not appear. So another way of tying dependencies is, instead of isolating them in a bundle, keep the functionality where it is, but start using optional dependencies. Now, that is a bit of a slippery slope. Import optional dependencies can start to make your code harder to understand, harder to reason about, but it's a valid option. Where it becomes a bit more interesting is if you're using declarative services. So one problem that I personally had when trying to use optional dependencies is that if you have reference to optional components, and then declarative services runtime tries to instantiate that certain component, it will log an error. Very helpfully, because it says, well, I cannot find the class that you reference in this component. And then you get a big, scary error log warning, which is completely correct, but also completely useless, because I know I should be getting that. So one pattern/workaround that we found is have a component which is, by default, is disabled. And then you have a starter component that manages its life cycle. So when it starts, it tries either to look up a dependency of this my component or even the my component itself and tries to enable it, right, using the declarative services API. And then if it fails, it says, well, sorry, I cannot fail. And the whole reason for having this starter is this info, logging info versus logging an error. So Minimal impact, but I think it's a bit of a less than natural pattern to prevent error log entries. And also, it's a sign that your bundle is doing too much. It's trying to reach out into way too many other features / bundles / domains, and you probably should try and refactor it. Overlays. When you have a service, an OSGi service, let's assume that you have this consumer guy that reaches out to a certain component that is defined by the interface foo. You usually have your single implementation, let's call it the default implementation, that is a component, and it gets wired to this reference. What you can do is define another component which has a higher service ranking. And this is my better implementation. And what you want to get is that this foo reference here goes to the better implementation, not to the default implementation. Where things get a bit complicated is that by default, references are reluctant. So what that means that if you get bound to a reference, you keep it forever. And if the default implementation happens to be the first one that is bound, it will not get replaced with that better implementation. So what you want to do is to have a greedy reference policy. So again, it's not a very difficult mechanism. It's understood. It's well documented. The only downside, the major downside that I see is that you need to explicitly say, hey, I want this component reference to be greedy. Replace it whenever something better comes along. And well, another, let's say, minor downside is that if you're starting to manage multiple alternative implementations, it can become hard to think about which service ranking should go where, right? So if you have 0, the default implementation, 1, you give it 1, or 100, or 1,000, that's fine. If you want to manage 10, then you start thinking about which ranking they should get. But usually you don't run into that. Another pattern that I've noticed from time to time is that you have a feature which is hiding underneath in another feature. So let's say that we have this messaging and inventory features, and then you have a blobs functionality that was developed and hidden inside this messaging feature. And what usually happens is you want to take away one of the components, and inventory depends on blobs in a hidden way, and when you take away messaging, you suddenly that inventory module stops working. So what you need to do is extract this blobs feature to be its own standalone and sort of rearrange the layers of your architecture. Now, that's always a good and satisfying thing to do, right? Start extracting, refactoring. I like it better than delivering features, to be honest. But what can happen is that dependencies spiral out of control. So you extract a sub-feature, and then you see that that sub-feature depends on something else, and soon you have a big ball of mud on your hands. You're trying to untangle it. But usually it goes pretty well. So that did it for the OSGi stuff. Let's go for content packages. In the same way that we sort of had glue bundles, we can call this glue components or guard conditions. The render condition is a way that you have in AEM to, conditionally render content. You can say, hey, render condition only if this condition render content only this condition holds true. And this one is actually a code sample from ACS Commons. They have some reporting stuff where they need to check if handlebars is available because they use that as a scripting engine. And actually it was something we discovered while sort of refactoring and modularizing AEM. So the pattern actually is quite simple. Try to load the class or do whatever check you need to do. And if it holds true, return true. If it doesn't, well, just return false. And that condition, the content will no longer be rendered. Again, a very established pattern. The only criticism that I would have is that it, again, sort of puts modularity at the class level, which is not where, in my personal opinion, where it should be. It should be at the bundle level. Overlays. Now, this is a bit of a made-up example. Let's pretend this is a very simplified workflow definition. So what happens is that you have class references, have class names in content. And at the current time, you have no way of knowing whether that class is available at runtime. So you build your system, you deploy everything, and then sometimes later a workflow execution kicks in and it fails spectacularly because the code dependencies aren't there. So the pattern that we recommend is overlaying, is supplying alternate definitions at runtime, at build time. When you package your application, make sure to supply alternative definitions for such workflow definitions or whatever. It can be a bit surprising at runtime, so you know you deployed A, but what happens is B. On the other hand, it has minimal impact on your existing code bases. You do not need to do the big refactoring to make your system work. Now, this is one of my favorites. Inlining is, well, actually a fancy name for copy-paste, and I'm actually on record saying this. So copy-paste is not a crime. We're doing software engineering, everything has a cost and a benefit. And sometimes you need to weigh in the benefits at the code level or that are inside the module to the benefits that happen at the architectural level. If you have a really nasty link between two modules that really shouldn't happen, and you can solve it by copy-pasting 3 lines of code from module A from module B, my personal preference is just do it. It's a smell, it's not a crime to copy-paste a little bit of code. And I found this somewhere on the internet, that's the rule of 3. First, you write the code, then you duplicate it if needed, and the third time, you actually have 3 use cases for that same code, you refactor it. Of course, it's a rule of the thumb, it's not the law, but I think it's a decent rule of the thumb. Refactoring and abstractions have a cost, and you should always look into whether the benefits are actually worth it. All right, well, that was the wrong title, sorry. A very practical point here is that whenever you can do things, you should prefer doing things at build time to things at test time, and worst of all, at runtime. There are ways of checking, for instance, that package imports and exports are satisfied at build time as opposed to waiting for the application to start up. That is a sample, I think, from one of the Sling feature plugins. The point is try to move everything as soon as possible at build time. You will gain a lot of time, especially if you have a large application. If you're waiting for EM to start up in 5 minutes or whatever it takes to start, it is much, much faster to just analyze some JSON files than to wait for things to blow up at runtime. Also on the tooling level, there is some support of checking of generating package imports for content packages. So if you could do check these content packages to see if all imports are satisfied, that is a plus. If you can generate constraints for workflow definitions, right? The examples we had a couple of minutes ago, to see if all the classes declared as workspace workflow steps are defined, that's a plus. And you can think of extending this in all sorts of tooling, maybe client libraries and whatnot. And now here, please have the magic stick. The nice slides are back.
Okay. So I'll just a few words on modularized testing, because that actually is like, I think we had the hardest discussions internally about this aspect, and this cost aspect of that. Because if you think about shipping modularized, and there is like each of those modules that you decide to now have and to be able to take away adds further permutations. And this can be a combinatorial nightmare. But face it, like if you look at it, what you can do with all the modules that we have in there and all the bundles and service that we have in there, you have tons and tons of configurations. And those hundreds to thousands of configurations already create this kind of combinatorial nightmare. And just the absence is just adding one other set of configuration to it. So we are already in this combinatorial nightmare. And what we did for that already is you have to look at what is really creating value, what kind of tests are creating value. So for us, we did optimize our CI/CD pipeline to still have this one CI/CD pipeline for everything being installed and having integration tests running on everything and various combinations of configurations. But we extended it to have upfront something that is, I think last year was also presented, is the evergreen sprouts, how we call them, is basically an on-demand way of declaring tests, test runs that run on the snapshots on the current state that teams, so the module teams can declare own tests where they see a need of, like, okay, if we disable another module, we want to test our own tests. And we can run significantly longer tests because the module team can decide on how intense those tests need to be. Because before we had kind of the limitation with the growth that and each addition of tests extended the time it took to pass through the pipeline. We shifted this effort to the module team so that they can test a lot earlier and decide on their own what kind of combinations really affect the specific modules, so we can keep the effort for that under control. So just to cut it short now, for the summary, like, what did all of that mean for AEM? Like, where are we right now? So what we did reduce the API surface, like the external one. You probably have noticed in AM 6.5 already, there was quite a significant cut on the API that was not used because some of the tooling that was just set up for the feature model allowed us to analyze also what is actually being used and what is necessary. And also we could look into having a core product, like everything is not about those additional modules, what is necessary to have that. We have, for the core product, a faster install and startup time. Like, yeah, the footprint was reduced quite significantly, more than we anticipated before. Same for memory usage and disk footprint. And all of that going into the direction of, like, what we heard this morning also, we want to be able to ramp up AEM and the core service of AEM as fast as possible and really just use the stuff and ship the stuff that is necessary for the service that you want to offer for the customer. And the last part, yeah, testing became more complex and teams had to take over ownership. And this also came along with, like, we even had internally some kind of reorganization, like probably have heard from Microsoft Unified Engineering as kind of term, like how we, like the testers are now a lot closer to the developers. Basically, they are part of the team. And this kind of change helped us also to set up these kinds of patterns with those sprouts and made it possible that we can have these kind of rapid iterations and work more on isolated modules. So there's one thing just to close it, that is what we still don't know is how all this modularization will have a concrete impact on you. This is because, A, we don't know what kind of modules we might come up with and ship in a certain way. And also, we currently don't know how you see all the effort that we have put into that, specifically in how to declare internal versus public API, and so on and so on. So therefore, we would want to invite you to get in touch with us, hear about your experience over the last 2 years where we started to put in those things into place, also the analyzers, and if you have tried them out and how they worked out for you. In case we can't make it in the QA now, we are around for the whole conference. Get in touch with us. Yeah, and that's it. Thank you.